So now we're going to work on solving word problems with exponential functions. We did do few word problems previously, and then I explained the different kind of functions for you, exponential functions, but we're going to also look at them again. Okay? So things that you need to remember are that it depends on how it goes. You have basically 4 equations that you're going to look at. Okay? And the 4 equations are right here. You'll see different letters, and the letters should not kind of make you lost. Okay? It means the same. So I'm gonna talk about the letters and what they mean, and then what letters can you use. The letters, again, you can use whatever letters you want. A letter is a letter. You can say let A be the amount, let B be the amount, whatever you guys want to use. So the 4 equations are the growth, decay, half-life, and doubling. Okay? We talked about the growth, and we said that the growth is when you have, so your value is equal to, previously we used Y. Okay? Now we're going to use A for amount. It's equal to, the letter A0 means the amount initially. 0 means X equals 0. Okay? So this is the initial amount. And then we said it's 1 plus the rate to the power of n. Do you guys remember that? Okay. So A is the amount, so that's your final amount. So that's the amount that you're going to find at a certain point. A0, that's your initial. It's also called, they also refer to it as A0. So that's the initial value. I is the rate in decimal. So this I use when I have growth rate. And n is the number of years. Okay? So this I use when I have growth and when I have a percentage, right? So when they give me like a growth rate of 2% or a growth rate of 10% or a growth rate, so in the question it will be a percentage. Okay? Similar to that would be your decay. So with the decay, again, you're going to have a rate, but the question will be saying it's depreciating by, or it's decaying by, or it's decreasing by. So you'll have the word that tells you that it's going down. Okay? So again, it's a percentage, and then the formula is the same, but with a minus in. So it will be 1 minus I. Then we have special types of equations. And the special types of equations are the half-life and the doubling life. Okay? So the half and the double. So in this case, the question will be telling you that your function or the number or the population or whatever it is doubling. Okay? So right away you know that instead of using the 1 plus I, you're going to have to use 2. Right? Because you know that your rate is doubling. So you're multiplying by 2. Okay? So whenever the question says doubling, so this is one of the special cases, you're going to use, so A is your initial, A is your amount, time equals to A0, which is your initial value. Instead of 1 plus, you're going to use the doubling rate. Now, here is the difference right now. So you see how we use n here, right? We're going to use, so instead of n, I'm going to use t. Again, it's a letter, right? Which means in how many years you want it, how many times you want that to happen, okay? You want the answer for it. But the important part and the difference is that you have to divide t by d. And d is your doubling time. So, let me explain, let me give you a question. So let's say you have bacteria population, okay? And then it tells you that the bacteria doubles every 6 hours. Okay? So you know that every 6 hours you're gonna double, right? So if you look at this, so if, let's say we're going to start with 100, okay? So we're starting with 100 bacteria, that's at time 0, okay? What's going to happen, when will it double? When would I have 200 bacteria? At what time will I have the 200 bacteria? I just said it doubles every 6 hours. So when I have 200, it will be at 6 hours. Okay? Now, when would it become 400? At 12. Right? When would it become 800? At 18. Right? So what's happening is every 6 hours, right, I'm doubling. So that 6 hours, that number 6 is gonna go in for D, right? And then if I ask you, what would your population be after 24 hours, right? So what you do, you go like this. A equals, initial is 100 because that's what I'm starting with, 2, 24 because the question is asking you, what would your population be in 24 hours, right? So that's your T, and then divided by your doubling hours, which is 6. That 6 is never gonna change, right? In this question, right? That 6 is gonna stay there. What's gonna change is if I ask you, what would your population be in 48 hours? Then you plug in 48 in for 24, okay, and 14, right? Or what would the population be in 27 hours? You plug in 27 in divided by 6. Do you understand what I'm trying to say here? Okay? So most of the time in the scenario of grade 11, the doubling time is going to be given to you. If it's in years, in days, in hours, it's going to be given to you. Okay? And then most of the time they're going to ask you, let's say, what would the population be in so many time? Okay, which you need to plug in 15. Now, some cases, they will ask you to solve 14, but I won't be asking you that in grade 11 because we're going to have to learn how to do that in grade 12. Okay? Are you guys okay with this? Do you understand it? Okay. Now, similar to that, we have the half-life. Okay? So the half-life, again, this is a special case where you're actually cutting your amount by half at a certain period of time. Okay? So you're going to have the same thing. The A, which is your amount. A naught is your initial value. It's a half, so that's a decreasing function, right? It's a decaying function because your base is between 0 and 1. And then you have T over H, where H is the half-life time. So similar to the other question, if I say that you have a bacteria, right? And then it's decaying by half every 6 hours. So that 6 is going to be your H time, okay? And then A naught's going to be 100, and then you're going to have to solve for the question, okay? So usually, again, they will be giving you the H, which is the half-life time. And that H will not change during that question. Are you guys okay with this? So, for different formulas that you probably have to pick from if you have to make up that equation. So let's look at these two examples. So you have a principal of $500 is invested at 8% per year compounded annually. Write an exponential equation to represent the relationship. So, which formula do I use? Is it growing? Is it decaying? Is it half? Is it double? You guys have to tell me.
It's growing.
It's growing, right? How do you know it's growing?
It says
It's because it's invested at 8%. It's not removing. You're not removing. You're earning 8%, right? So I know that I have to start with the equation, which is A equals A0, 1 plus I to the power of n. What's your initial amount? What are you starting with? $500. Now, again, I'm showing you steps here, but when you're actually doing the question, you don't need to show all these steps, right? But I'm just showing you steps so we don't do it all at once. Now, so subbing the common ratio, which is in this case, usually if you're remember, if you have A equals AB to the power of X, your common ratio would be the B, right? But in this case, I have a special case with a percentage, okay? So I have to do the 1 plus I. I know that, right? Because it's a special case, I don't have the rate. So, the special case, so you have different cases here. So double, you use what for B? What do you sub in B if it's doubling? 2. How about half-life?
0.5.
0.5 or 1/2. How about if it's triple? 3, right? Triple means 3. Right? Depending on what the situation is, right? You're gonna replace that. Now, we said that if we have percentage, we're gonna change the percent into a decimal, and then for growth, we're gonna do the 1 plus the I, and then for the decay, we're gonna do the 1 minus the I. Okay? So in this case, I have to do A equals 500, 1 plus, what's my percentage?
1.08.
So, I itself, I is 0.08. Right? So when you add them, it becomes 1.08. So that means my equation is A equals 500, 1.08 to the power of n. Right? Now,
means 0.0.
that's right. You divide 8 by 100. Okay? Now, the question is not specifically asking you what would your amount be in so many years, right? So you have to leave it as n. You can't plug in anything for n. Unless the question says, what would your amount be in 10 years? Then you plug in 10 for n. Okay? A lot of students, this is where the confusion it becomes, is when, what do I plug in for n? But the question is not asking you anything, right? The question is asking you just find an equation, right? So n has to stay as n. Until I ask you later on, find the amount after so many years. Make sense? Okay. Now I want you to try the next one. See what you guys can do for that. So a new car costs $20,000. Its value decreases 16% per year after it is purchased. Write an exponential equation to represent the relationship. So remember that the question is asking you just to write an exponential equation. It's not asking you for the value. So what would be my generalized equation?
A equals A. Well, it's going to be 1 minus I.
That's right. And it's 1 minus because it's a decrease. What's my initial value? So I'm going to replace A0 with 20,000, and then you will have 1 minus I to the power of n. Now again, you can skip that step, right? You can go right away from this step to this step where you plug in the A naught and the I all together in the same equation. But I want the generalized form. What would be I? 0.16 to the power of n. And then you just do, what's 1 minus 0.16?
0.84.
Yeah, to the power of R. Okay? Then the question would become, if I want to extend this question, I'll be asking you what would the value of the car be in 7 years. Then you plug in 7 for it. Okay, and then you find it. Do you understand that? Any questions?
How to read the hint? What happened to the hint?
How do I read, sorry? This one?
No. What happened at the hint? At the end.
Right here? So what happened between this and this? Or what happened here?
No, I mean a new car cost this much and
Yeah.
the value decreasing at this per year after this purchase, write an exponential. It's just an exponential.
Exactly. It just asks you to write an exponential equation. That's it. So you have to stop there because that's what the question asks. Yeah. Are we good? All right. So, a population of Alberta between 1987 and 2005 can be modeled by an exponential equation. The population in 1987 was 2.4 million and the growth rate was 1.7 million. Write an equation to model the situation. Now, in this case, they're giving us a year that we're gonna say that this is our initial year, okay? So when they give us years, it's a bit tricky, okay? Because we're gonna have to say that 1987,
Before you do money sum?
after, yes. So 1987 is my initial year. So 1987 represents 0, right? So when I do my, let's say if I'm trying to graph here, so the year, right? I don't do 1987, 1988. I actually do 0 as 1987. 1988 would be 1. 1989 would be 2. You see what I'm trying to say here? So we're gonna say that 1987 is our year 0. Okay? So the population in 1987 was 2.4 million. What does that 2.4 million represent? The initial population. Okay? So the amount is equal to, so what am I going to use? Which formula I'm going to use? Growth. So A0, 1 plus I to the power of n, right? Where A is the population in million, right? So you have to specify. And n is the number of years since what year?
1987.
Since 1987. Okay? So you have to specify this. Otherwise, when you do your math, your population is going to be 2.6, let's say. 2.6 people? Like, what does that mean? Right? So you have to specify that it's in million, and then you have to specify that n is the number of years since 1987. Okay? So these are the two specifications that you have to use. Now, let's fill in the blanks. So what am I going to fill in for A0 or A0? 2.4. And then what am I going to fill in for I? 0.017. And then for n, it's going to stay n because the question is only asking me to find the equation.
Could you not just write 2.4 million out?
You can, but if you do, then you just say A is the population. You don't say in millions. Okay? But then you'll have a big number. Now, use your model to calculate the population in 1985. So what do you plug in for n? -2. Why -2? Because you're going down. Remember your initial value, which is 0, your initial time is 1987, right? So 1985 is 2 years before that. So I have to plug in -2 for n. So what does your answer end up? Make sure you put your brackets properly, because bed mass is very important, right? So what would your answer be?
Which decimal point you round it to?
Sorry?
Which decimal point you round it to?
What do you have?
0.096252948.
So 2.0, let's do 3 decimal place. 2.096. Is that what you got? Is that what you got? 2.4. Remember, you need to include the very first statement. Okay, good. Okay, so therefore the population in 1985 was 2.096 million. Use your model to calculate the population in 2012.
Is that -25? Positive 25?
So what do you do to find what n is, so you don't guess?
Right. 25 minus?
You do 2012 minus 1987.
Oh, okay.
87, right? So what do you get?
25? Is it right or is it wrong?
What did you get? $25?
Yeah, 25.
So what you plug in is 25 for n. So what do you get when you do that? $13.02526. Are you guys okay with this? Okay. So, was there any other questions, Dale, in the package that were not covered in this lesson? Like you said? Like the word problems? Okay. So what I want you guys to do, I want you to keep working on like the homework package and that review booklet. Remember that your test is on Wednesday. So basically you have Monday and Tuesday also to review.